Today's notes are on solving three variable systems. The important thing to remember when you're doing this is to keep calm. It can be a little overwhelming. These problems seem like a lot of work, but when you are all done, you can show off your awesome algebra skills. Don't worry if you can do substitution and elimination, you can do this. The method of solving three variable systems is essentially doing 3 sets of elimination and 2 substitutions. Depending on the problem though, you might be able to solve it doing less. So here we go. Your first step is going to be your first elimination. You are going to find equations with variables having leading coefficients of 1, and we're going to eliminate them. So the second equation and the first equation, they're going to use to eliminate y. So here's your equation 1, equation 2, and equation 3. So in order to eliminate the y's, they need to multiply to get opposite coefficients on a variable and do elimination. The new equation has only 2 variables, and they will call this equation A. So this was from equation 1. This one was from equation 2, and they found it by multiplying that equation by 2 in order to create a cancellation with the y's. This is your new equation then, which we're going to use as A. Then you're going to work on the second elimination. Because you eliminated y's in the first elimination, we want to eliminate y's again. So we want to eliminate the same variable. So this time it's using the second and the third equation. So here's the third equation. This was the second equation, but it's been multiplied by -3 in order to get this cancellation of the y's. We are then left with a new equation B. We move down to the third elimination. The third elimination tells you to use your new A and B equations and eliminate a variable and solve for the remaining variable. So because these two equations only contain x or z, I have to choose to eliminate one of those. So it's using equation A and equation B from above. So here's our B being moved down. Here's equation A being moved down. And notice that they've multiplied equation B by 7 in order to eliminate the x's. Now I have -18z equals -72, which tells me that z is equal to -4. I'm now done with elimination and I'm switching to substitution. For the first substitution, I'm going to take z equals 4 and I'm going to substitute it back into either equation A or equation B. I can't plug it back into one of the 3 original equations because if I plug in just z, I'll still have x and y that I need to solve for. So if I plug it back into equation B, they then found that x equals -3. Your second substitution is going to be found by plugging in your x and your z value into one of the original equations. And you can plug it into any of them. So now they're going to use the second equation in this example. They plugged in x and z and they solved for y. They got y equals 2. Your solution is going to be an ordered triple. So just like our solutions before were ordered pairs, you want to write this as the ordered triple x, y, z. Let's flip it over and go through a problem together. Alright, to start with example 1, I'm going to label my equations. So this is going to be equation 1, equation 2, and equation 3. And I need to start by deciding which variable I want to eliminate. I'm going to start by eliminating z. So I'm going to make a note here so I can keep track of everything. that this is my first elimination. And I'm going to choose to start by using equation 1 and equation 2. And we're going to try and eliminate z. Right, equation 1 and equation 2 are actually all set up for me. I have a positive 1z and a negative 1z. So I'm just going to rewrite the equations here. And if I add them together, my z's should cancel out. I'm left with 7x plus 2y equals 25. And this is going to be my equation A. Then I'm going to look at performing my second elimination. And I want to eliminate z again, so now I have to pick which two different equations I want to use. So I'm going to say that I'm going to use equation 1 and equation 3 because 1z is positive and 1 is already negative. So the first thing I need to do is multiply the first equation by 2 to get 4x plus 2y plus 2z equals 6. The third equation I don't have to multiply by anything. I have 6x plus 6y minus 2z equals 4. So if I add these together, I get 10x plus 8y, my z's cancel out, is equal to 10. This is my new equation B, which is going to lead us to our third elimination. Now I'm going to be using equation A and equation B, and I can choose to eliminate either x or y. So for me, I'm going to pick to eliminate y. So I need to take equation A and I need to multiply it by negative 4 in order to create a negative 8y. So I'm going to get negative 28x minus 8y equals negative 100. My equation B, I don't have to multiply by anything. So I have 10x plus 8y equals 10. And I'm going to add these together. I get negative 18x equals negative 90. If I divide both sides by x, or by negative 18, I find that x is going to be equal to 5. Right, we're now going to complete our two substitutions. Alright, so the first thing I'm going to do is to substitute x equals 5, and I can plug it into either equation A or equation B. So I'm just going to pick B. So I get I'm going to rewrite this. I had 10x plus 8y equals 10. So I'm going to replace the x with a 5. So I'm going to get 50 plus 8y equals 10. And if I subtract 50 from both sides, I get 8y is equal to negative 40. And if I divide both sides by 8, we find that y is equal to negative 5. This is going to lead us to our second substitution. And I'm going to be plugging in x equals 5 and y equals negative 5. And you can plug them into any of the original equations. I'm just going to pick number 1. So my first equation was 2x plus y plus z equals 3. So I'm going to have 2 times 5 plus negative 5 plus z equals 3. So we get 10 minus 5 plus z equals 3. Or 5 plus z equals 3 by combining like terms. Then if I subtract the 5 over, I get z equals negative 2. Your final answer are going to be these 3 written as an ordered pair. So you're going to have 5, negative 5, and negative 2. And that will give us our final answer. Please try to do example 2 on your own.